Hi viewers, welcome back to our channel. Actually, in our last video we discussed about the construction of square root spiral, that is representation of irrational numbers on number line. Actually, in that method, to locate an irrational number, we must know the location of previous number. Today also we are going to discuss about the representation of irrational numbers, but that is geometrically. In this method, no need of the location of the previous number. We can represent an irrational number directly by this geometrical way. Okay? Actually children, you are feeling hard, but I am going to give you some steps. If you follow those steps, it will be very easy. You will feel easy. Okay? So please do concentrate. Okay? I am giving the steps on screen also. You can take the screenshot. See children, I have written the steps here. We must follow these steps to represent an irrational number on number line. Then you will feel easy. Okay? Now see, example here I have taken root a, where a is equal to any natural number. As a natural number I am taking a 3. Okay? Now I am going to represent root 3 here. I am going to represent root 3 on number line. Let us see the first point. Mark the distance of a units. At the place of a, I have taken 3 here. Okay? So mark the distance of 3 units and take it as AB. Mark the distance of 3 units and take it as AB. Okay? Let me mark the 3 units here. 1, 2, 3. Okay. I am marking as AB. Okay? Firstly, I have taken the distance of 3 units and I have taken as AB. Okay? Let us go for next point. Extend the length by 1 unit and mark C. Okay? Extend the length by 1 unit and mark C. Okay? Now I am going to extend this by 1 unit. 1 unit. And now I am going to mark as C. Okay children? Firstly, I have taken the measure of 3 units. Firstly, I have taken a line by 3 units and then I have extended till C by 1 unit. Next, let us go for the third point. Find the center of AC and mark it as O. Find the center of AC and mark it as O. Firstly, I am going to mark the center here. See children, the distance between A and B is 3 units and B and C is 1 unit. Means the distance of this AC is 4 units. Then what could be the center here children? What is the center mark? Here it is the center mark. Here it is the center mark. Okay? Now, see children, here you can also mark the center geometrically by taking the radius more than half of this AC. Okay, let us see here. More than half I am taking, more than half, and by drawing the arcs this side and also this side. And without changing the radius with center C, I am intersecting the previous arcs. And if you could join this 2 meeting points, you will be getting the center point. You will be getting the center point. See here, it is the center point. Okay? You can mark the center geometrically, otherwise you can mark the center directly by taking measure. Okay? Now it is the center point. And see children, next point, draw the semicircle with center O and radius OC or OA. Now I am going to draw the semicircle. Now I am going to draw the semicircle with radius OA. Actually here center we have to mark as O. Okay. Now we are going to draw the semicircle with radius OA or OC. Okay. Let me take the radius of this OC here. It is OC here. Okay. Now I am going to draw the semicircle. Yes. It is a semicircle I have made. And next, draw a line perpendicular to AC passing through B and intersecting the semicircle at D. Now we have to draw the perpendicular which is perpendicular to this AC and it must pass through this B here. It must pass through this B. And the meeting point of this perpendicular and this semicircle we are going to mark as D. Okay. Let me draw the perpendicular here. I am drawing directly by set square here. It is the perpendicular and it is intersecting at D. Now I have drawn the perpendicular which is passing through B and the intersecting point of this line and also semicircle I have taken as D. And next point, find the distance OB. Find the distance OB means distance between this O and B I am going to find here. Distance between this O and B I am going to find here. Children, actually, what is the distance between this AB, my dear children? Distance between AB is 3 units, right? Distance between this A and B is 3 units. Now I need this OB. Now I need this OB. And see children, this OB distance only I am going to find here. This OB distance only I am going to find here. For that, what I am going to do, you must observe here. From AB, I am going to subtract this OA, that is radius. This radius is 2 units as we know, because half of 4 is 2 only. Half of 4 units is 2 only. So that from this AB, I am going to subtract this AO. Because see children, AO plus OB is equal to AB. As we know, OA plus OB is equal to AB. And AO is equal to, we have 2 units. OB we are going to find, and AB is equal to, we have 3. And if you could send this 2 to the RHS, then it will become subtraction 3 minus 2 means OB is equal to, I am getting 1 unit. This OB is equal to, I am getting 1 unit, my dear children. Now you just join this O and D. Join this O and D. See children, here OA, OC and OD are equal here, because this O and D also a radius. This O and D is also a radius, because radius is the distance between center and any point on the circle. Okay. Now the distance of this OA, OC and OD are equal, means it is 2 units, right? It is 2 units. Now we got a right angle triangle, that is OBD. We got a right angle triangle, that is OBD. Now what is the next point here? Find BD. Now we are going to find BD here. Now we are going to find BD here. See children, to find BD here, we can apply Pythagoras theorem. Yes or no? Pythagoras theorem. Hypotenuse square, that is OD square. OD square is equal to OB square plus this BD square. And see children, what about OD here? OD is 2 units, so that 2 square, it is equal to. What about OB? OB is 1 unit, so that 1 square, and plus BD square we are going to find, means BD length we are going to find. And see children, 2 square is equal to 4, and this one I am taking to LHS, then it will become minus, it is equal to BD square. 4 minus 1 is equal to 3, so BD square is equal to, I am getting 3 here. Now here we can apply square roots on both sides, okay. I am applying the square root on both sides here, and see children, square and root can be cancelled, and what is the phenomenon we have seen in the last video. And now BD is equal to, I got root 3 units. BD is equal to, I got root 3 units. BD I got root 3 units, means distance between this BD I got root 3 units. Distance between this B and D I got root 3 units, and this root 3 units only we are going to locate on number line. This root 3 units only we are going to locate on number line. See children, what is the distance between this B and C? Distance between B and C is 1 unit. So you just consider this B as 0. You just consider this B as 0. Then this C will become 1 unit, right? And just you extend this number line. You just extend this number line, okay? Just a minute. I am extending the number line. See here. Don't be confused. Okay. See children, now just take the radius of this BD. Take the radius of this BD and you just mark it on number line. Yes. See children, it is 1 and this mark is 2 and this mark is 3 and this is 4, right? Means the value of root 3 we got in between 1 and 2. We got between 1 and 2. As you know, root 3 value is in between 1 and 2. And when I am going to represent root 4 number line, it must coincide with 2, my dear children. It must coincide with 2. Let's see the one more example. For example, I am going to represent root 3.5 on number line.